Is Eureka Math. We are on Module 6, Lesson 12, and our objective today is to create a rule to generate a number pattern and plot the points. Okay, so let's go to the Learn book. Write your name on the Learn pages. Lesson 12. Write a rule for the line that contains the points 0, 3/4, and 2 1/2 and 2 3/4. Okay, so first of all, we're going to plot those points. 0 3/4 would be here, and 2 1/2 and 3 1/4 would be here. Okay, so I can make my line straight across. Now I need to make a rule for this, so I'm going to work up to it. Okay, identify 2 more points on this line. So here's a point at 1. So if x is 1, y is 1 3/4. Okay, so 1 and 1 3/4. And I'm going to call that point B. And C, let's see, we can find another one. How about right here at 2? 2 and 2 3/4. I'm seeing the pattern. Are you seeing the pattern? So that's 2 and 2 3/4. Okay, so this is plot C, and you know what? I'm going to call this one A and that one D. So that's A and that's D. Then I'm actually going to write those in. So I've got 0 and 3/4, and then here I have 2 1/2. And 3 1/4. Are you already seeing the rule? The difference between here is what's going to give you the clue. Find a rule for a line that is parallel to BC. So draw the line grid below. So here we've got y equals x plus 3/4. Okay? You see that rule right there? So if x is 1, 1 plus 3/4 would be 1 3/4. That's the y. And if x is 2, 2 plus 3/4 is 2 3/4. If x is 0, 0 plus 3/4 is 3/4. Okay? So there we go. There's our rule for the line we just made. Write a rule for a line that is parallel to BC. We're calling this line BC. Okay. And goes through points 1 and 1/4. I'm going to switch colors because I'm using a different line now. 1 1/4 would be right here. And I want it to be parallel. So that means that it's going to be y equals x and then plus something. Huh? Okay. So plus or minus, maybe. Remember when I said that x equals y is this line right here? Okay. So that's that line. We want a parallel line next to it, so we're going to put this parallel line right here. And go. And I'm going to call that line, I didn't give it a name for it, I'll just call it line A and line B. Line B would be x equals y, but then it's this far less. So if x is 1, y is 0. So that would be minus 1, right? Okay, let's try that a couple times. So, nope, 3/4. 1 1/4 and 1. Wait, 1. Oh, here I drew it wrong. That's my problem. 1 1/4 is not right there. It is right here. That's what I did wrong. Be very careful when you're plotting your points. So this is not -1, it is -3/4. So 1 and 1/4. If x is 1 and we subtract 3/4, we get 1/4 left. Let's try it with 2. 2 minus 3/4 would be 1 and 1/4. That's 1 and 1/4. Yep, that works. And if I had 3, that would be 2 and 1/4. I'm just testing my line here to make sure it's right. 1, 2, 3, and then 2 and 1/4 would be right here. Yes, okay, so that is our rule. Minus x, y equals x minus 3/4. Create a rule for the line that contains the point, I'm going to switch colors again, that contains the point 1 and 1/4, 1 and 1/4, and 3 and 3/4. One 1/4, that's the x and the y, and 3 3/4 there. Okay, so my line goes this direction. That is not parallel, so that's not, I think that's going to be more of a multiplication point. Okay, so let's try it again. 2 more points on this line. How about 2 1/2? So if x is 2, y would be 1/2. And then let's go all the way out to here. See, that line does not look like an addition subtraction line to me. That looks like a multiplication division line. Ooh, that's terrible. Okay, I'm going to stop that right there. And 2 1/2. Two and 1/2, and then that's G. This is tricky, you guys. Okay, and the next one, 3 3/4. What would 4 be? So it only went up 1/4 between each one, so that would be right about here. That would be the next one, and that would be 4 and 1. Okay, I see the pattern now. Do you see it? This is y equals x divided by 4. Now let's test that, right? So 1 divided by 4 would be 1/4. 3 divided by 4 would be 3/4. 2 divided by 4 would be 2/4, would be actually 1/2. And 4 divided by 4 would be 1. So that is our rule for that one. Okay, there's G and H. We'll put here. Okay, write a rule for the line that passes through the origin. Okay, here's the origin. I'm going to switch colors again. Let's try purple. Here's the origin, and I'm going to erase that XY line because we didn't use it for anything. There's the origin. Write a rule for a line that passes through the origin and lies between BC and GH, between them. Any old line? Well, we could just easily do y equals x. That would be right here. Okay, sure. Because GH is here and BC is here, and that's between those two. All right. I guess easier than we thought. Number 3, create a rule for a line that contains the points 1/4 and 1 1/4 using the operation or description below. Then name 2 points that would fall on each line. Okay, so create a rule for a line that contains the points 1/4 addition. Well, that's okay. Y equals x plus 1. Right? Because we've got 1/4 and 1 1/4. So if I did 2, x could be 2 and y would be 3. If I did x was 3, y would be 4. Okay. A line parallel to the x-axis, so that means that it has to go like that, which means that the y is always going to be the same. So our y here is 1/4. And we can put 2 and 3 here if we want again. 3 and 1/4. Oops. 1 and 1/4. Okay, multiplication. So this is 1, 2, 3, 4, 1/4. And this is 1 and 1/4. Okay, so multiplication would be, how did we get there? Times 5? 1 and 1/4. So y equals x, 5x. Let's see if that works. Y equals 5x. So 1/4 times 5 would be 5/4, which would be 1 and 1/4. Okay, so if x is 1, y would be 5. And if x is 1/2, then y would be 2 1/2. Okay. This is a little bit more complicated. You really have to think about what we're doing here. So a line parallel to the x-axis, which would just mean that y equals 1 and 1/4. There's no x there. X can be anything it wants. A line parallel to the y-axis. Well, that means that all of the x's have to stay the same. I guess it would look like that. So that would be x equals 1/4. So 1/4, 1/4, and here you can put any number you want. 1/4 and 3, 1/4 and 5. Multiplication with addition. Ooh, okay, let's see. X equals 1/4. So x let's see. Multiplication with addition. Okay, so let's say 1/4 plus 1 equals y. Let's see if that works. Okay, so here we've got, if x is 1, nope, that doesn't work. Let's see. I have to use my brain on this one, you guys. This one's hard. Okay, so plus 1/4. So we've got to have some sort of multiplication and then some sort of addition, right? Multiplication with addition. So here we've got x equals 1/4. we could do 4x plus 1/4. Nope, that's not right. I want to say 1x, but that's not helpful right now. Gosh, I have to tell you, I'm stumped on this one. Let's go see what the book has to say, because I am having difficulty finding the answer for that one. Let's see. Multiply x by 4x, and add 1/4. Yes, that's what I was going for. 4, there it is. Okay. So if x is 1/4, right? 1/4 times 4 would be 1 plus 1/4. Okay. So let's try a different number. 2, if x is 2, 2 times 8, 2 times 4 would be 8, plus 1/4 would be 8 and 1/4. If x was 1, it would be 1 times 4 is 4 plus 1/4, so 1 and 4 and 1/4. Okay. That makes sense. That's where I was going with it, but I just wasn't patient with my own brain. I had to go look it up. Okay, Mrs. Boyd asked her students to give a rule that could describe a line that contains the points 0.06, 1, 2, 3, 4, 5, 6, 6/10, which is here, and 1 and 8/10, which is here. Okay. Avi said the rule would be multiply x by 3. Okay. Y equals 3 times x. And if x is 0.6, 6 would be 1 1/8. Yes, that works. Ezra claims that it could be a vertical line. If it were a vertical line, it would just be x equals 0.6, 6/10. Sure. Okay, Avi, Ezra. The rule could be x is always, yep, Eric thinks the rule could be add 1.2 to x. Sure. Miss Boyd says that all the lines they're describing could describe a line that contains the point she gave. Explain how that is possible and draw the lines on the coordinate plane to support your response. So Avi said the rule could be multiply x by 3. So multiply x by 3. Let's give some coordinates. If x is 1, right? 1/10, 2/10, 3/10, 4/10, 5/10, 6, 7, 8, 9, 10/10. This 1 should be closer to that. I don't know why it's not. Okay, and 1, what was the rule, times 3? That would make the next line go all the way from 1 all the way up to 3, which is outside of our board. So let's go with something smaller. If x is 1/10, right here, 1/10 times 3 would be 3/10. 1, 2, 3. If x is 2/10, we would have 6/10. 1, 2, 3, 4, 5, 6. If x was 3/10, we would have 9/10. Okay, 4/10 would be 1 and 2/10 here. Okay, and then here, and there's our line. We'll call that line A for Avi. Okay. The next one, Ezra. Ezra said that it could be a vertical line, and the rule could be x is always 0.6. Well, that's easy to draw. I'll use blue. That would be right here. This is the point, by the way. And that is just like that. It's a vertical line. And we'll call that one Ezra. last one, I'll make it orange. And we're calling this one Eric. Add 1 2/10 to x. So if x is 1/10, y would be 1 3/10. If x is 2/10, y would be 1 4/10. If x is 3/10, it would be 1 5/10. If x is 4/10, it would be 1 6/10. Wait a minute, what am I doing wrong? Add 1 2 to x. So 6 is 1 8. 5 would be 1 7. 4 would be 1 6. 3, 1 there we go. Sorry, I got a little off track there. Okay. And this one is called Eric. And all 3 of those lines go through that point. See that? Cool. We just used 1, 2, 3 different rules. Number 5, create a mixed operation rule for the line that contains the plot 0, 1, and 1, 3. 0, 1, and 1, 3. A mixed operation, that means addition and multiplication. Okay, so we could say 0 times 1 plus 1, x equals, no. Does that work? Let's draw the line first. Okay, so that is 0, 1, and this is 1, 3. Let's see. Okay, so if that was a half and 2, we could say x times x times 2 minus 1. Nope, that doesn't work. Plus 1. Let's try that. 0 times 2 would be 0 plus 1 would be 1. Okay. 1/2 times 2 would be 1 plus 1 would be 2. Okay, that works. 1 times 2 would be 2 plus 1 is 3. Yay! Okay, there's the rule. And now let's see if we can plot some more points. So let's see, 1/2 and 2. And the next one could be 2 and 5, which would be right here. 2 and 5, we could go all the way up there. Write a rule for a line that is parallel to OP. Parallel to OP, so that means that it has to have these, this is this one, by the way. Let's go here. It would have to be y equals 2x, and then we can do something different with the addition subtraction. That's what makes it parallel, so let's add 2. And 0 times 2 plus 2 would be 0, 2. I'm going to use a different color. 0, 2, okay. 1 times 2 would be 4, 1, 4. 3 times 2 would be 6, 7, 8, so that's going to be way up here. Let's try 1/2 times 2 would be 1 plus 3 would be 1/2 and 3, okay. And let's see if we can get 1.5 times 2 would be 3, 1, 5, right? 1.5 and 5. There's our parallel line. Oop, right there. Oh, I accidentally hit the button on my marker. There we go. Parallel line. Excellent. Tricky business, this, creating rules. I hope that you're understanding it. I think this is a bit of a 6th grade skill, but I think you can do it. Let's see what the exit ticket looks like. Write the rule for the line that contains the points 0 and 1.5. So that's here. And then 1.5 and 3, which would be here. So you have to make a rule that fits that. Okay, so you can look for some other points and then figure out how to make that. Y equals what? Okay, good luck. This is hard. Use your brain.